Okay, this next test is not going to be easy. I'll just tell you that now. This is not one of the easier tests. You have to get good at using your calculator. And the way you do that is by doing the homework. You gotta know, you gotta be switching back and forth between radian and degree mode. You gotta know when to put it in what mode and, oh my goodness. Okay, you know, I don't know, man. So what, no, like, we're not gonna have lecture today. You just figure it out on your own from the notes. Okay, we'll try it. People, if you have more than half the problems they can't do, you gotta come in for help or something. Okay, A and B are at the same stage, they're 10 meters apart. The angles of elevation are 43 and 51 degrees. What is the height of the tower? Do you see any right triangles in this problem? Yeah, I see two, so you can do SOHCAHTOA, right? Anytime you have a right triangle, just use SOHCAHTOA. So why do we call that Y? Okay, look at this triangle. What can I write? What equation can I write? If you have the angle here, this is opposite and adjacent. Which of the trig functions has opposite and adjacent in it? Tan. So tangent of 51 degrees is equal to x over y. And then now look at the big triangle. Tangent of 43 degrees is equal to x over 10 plus y. Two equations, two variables, solve it. And you get to use your calculator. Now this is degrees now. Okay, now there's two ways of doing it. One way is to work out the algebra. The other way is, since you're using a calculator, just use your calculator. You know how to solve any equation on your calculator, right? You just got to be able to punch it in. So what do you have to do? You got to make an equation of one variable. So solve for y in one equation. Okay, let's solve it for this one. So in this equation, y equals x over tan 51. Is that right? Take that and plug it into this equation. So you get tan 43 is equal to x over 10 plus x over tan 51. Now I could solve this equation, by doing algebra, but why? You have your calculator. You can solve any equation on your calculator. All you gotta do, make one side 0 and graph it on your calculator. Wherever it crosses the x-axis, that's your answer. That's what I would say to do. I will let you do that though. But then, I guess your calculator should be in degree mode here, right? Or you have to put in the degree sign to override the radian mode there, yeah? So you guys gotta practice that. I think every other year I put this problem on the quiz. Okay, number 2. Did we draw a picture? Okay, here's a cube. Find the angle formed by the diagonal of a cube and one of its edges. Okay, how do you want to draw this? Well, the diagonal goes from one point to the opposite vertex there, like that. That's a diagonal. Find the angle that it makes with one of the edges. Okay, which edge you want to find the angle with? Because see how this diagonal goes? It meets there. So there's, right at that point, there's 3 edges. This one, and that one. Okay, which one do you want to do? It doesn't matter because they're all equal, right? Shall we do this one right here? Okay, whatever. Okay, find that angle. I don't know. Well, what are we learning? We're learning trigonometry, the study of triangles. We need to draw in a line to make a triangle. Where can I draw in a line to make a triangle? How about like right there? And then, can you see that this is a right angle right there? Wait, that's not a right angle. Or is it? Wait, what am I doing? Yeah, that's a right angle, isn't it? Yeah, that's a right angle, duh. Okay, so how do you find this angle right there? Well, if you have a right triangle, you can use SOHCAHTOA. We just have to know the sides. We need 2 of the sides. Well, do we know what this side is? No, but it's a cube, so you wanna, what do you wanna call it? 1, 2, okay, 1. Now if this is 1, what's this right here? That's root 2, because that's 1 and 1, and right there's a 45, 45, 90 triangle. So that's it already, right? So here's the angle. This is the opposite. This is the adjacent. Which of the trig functions is opposite and adjacent? Tangent. So tangent theta is equal to opposite over adjacent. So if you want to find theta, you just go tan inverse root 2. Punch it in on your calculator. And if you're in degree mode, your calculator will give you a degree measurement. If you're in radian mode, your calculator will give you a radian measurement. Remember, inverse trig functions are angle measurements now. But don't worry, on Monday's quiz it's going to say, give your answer in degrees or give your answer in radians. So you've got to give them the proper one. Thank goodness you can do number 3, because I did the 10 gun and you can do the 9 gun. Okay, number 4. This problem has been on the quiz before. Okay, this is theta. Now we don't know what the radius of the circle is, so it really doesn't matter. You can call it r, you can call it 1, it doesn't matter. Okay. It says perpendicular, so right angle here. Find the angle theta so that the area of the sector is equal to the area of region RQP. So the area of this sector here is equal to the area of this here, this speckled region here. Okay, how do you find the area of a sector? What's the formula? It's in the notes. We went over it yesterday. 1/2 r squared theta. Do we have to know these formulas for the quiz? Yes! Until you finish your math career. And that's going to equal to the area of the speckled region. How do you find the area of the speckled region? Look at the pic. This is simple geometry. How do you find the area of the speckled region? Isn't it the area of the triangle minus the sector? Okay, so how do you find the area of the triangle? 1/2 base times the height. Okay, except we don't know what the height is right now. That's what we've got to figure out. Minus the area of the sector, which is 1/2 r squared theta. Okay, now we've got to figure out what the height is. But look at this triangle. It's a right triangle. I can use sokotoa, right? So which ratio am I going to use? If this is opposite and adjacent. Again, tangent. It's like almost every problem we use tangent. Tangent theta is equal to opposite over adjacent. Therefore, h equals r tangent theta. That's what you plug in for h here. Here, just plug it in. So what do we have now? 1/2 r squared theta is equal to 1/2, if I plug that in, r squared tan theta minus 1/2 r squared theta. Can I divide everything by r squared? Yeah, because it doesn't matter what the radius is. Okay, now, how do you solve? You can't solve these equations by hand. That's why you get to use your calculator, people. How do you solve any equation on your calculator? You make one side 0, you graph it, and you see where it crosses the x-axis. So, what are you punching on your calculator? y1 equal? Which side are you going to bring everything on, the left or the right? Make one side 0. Which one? Bring it on the left? Okay, whatever. So if you bring this over, you're going to have theta with x minus 0.5 tangent x, right? So you graph this on your calculator. See now, you're graphing a trig function on your calculator. It has to be in radian mode. If you are in degree mode, that's sorry, because it's all over our problem. Anytime you graph a trig function in radian mode. Graph this on your calculator, see where it crosses the x-axis. But please set the window. What does x represent in this problem? Theta, this angle. Can you see that that angle cannot be bigger than 90 degrees? So when you set your window, you should make x min 0 and x max pi over 2. Pi over 2 is 90 degrees, right? In radians. Because otherwise, you press the graph button. The graph will be crossing the x-axis plenty of times, but you got to look at the in the domain of the problem. Oh boy. So you guys better practice that. Because the answer's on the bottom. Okay, number 6. Oh, thank goodness you can do number 5. Find the area. Okay, now there's going to be plenty of these problems on the test. Well, not plenty, but several of these. I'm going to give you a quadrilateral. You have to find the area. Well, obviously, we're learning trigonometry. We're studying the study of triangles, right? So I'm going to have to draw in one of the diagonals to make 2 triangles. So which diagonal should I draw in? A or B? A! Why is A better? Because then you got a right triangle you can use, right? 6, 8, 10. Oh, I know how to find the area of this one. How do you find the area of this triangle? 1/2 base times height plus, okay, now how the heck do I find the area of this triangle? Well, in order to find the area of a triangle, you either have to know all 3 sides, if it's not a right triangle, right? Then I can use Huron's formula. Or you have to know 2 sides and the included angle. SAS, so you can use the 1/2 AB sine C formula. Do we know what this angle is? Yes! Because what's this angle here? Tan inverse 8/6, right? This is a right triangle, so opposite over adjacent. This angle is tan inverse 8/6. So therefore, this angle here has to be 115 minus tan inverse 8/6. And that's degrees now. So you got to put your calculator in degree mode now. So what's the area of this triangle? 1/2 AB sine C. And again, if your calculator's in radian mode here, you're out of luck, Charlie. Because that's a degree measurement. See, these problems really aren't that hard. They're just fun, right? No, you wait till you see the ones you'll get tonight and tomorrow. Oh man, it'll blow you out of the water. Okay, we have a circle, radius 5. The measure of the central angle is 2 radians, so that doesn't look like it's more like that, right? Right? Because 1 radian is about 57.3 degrees, so 2 radians is 114.6 degrees. It's going to be bigger than 90. Okay. Find the area of the segment. Now, I told you what a segment is in your problem. After today, you better know what a segment is, because I guarantee you this is on the quiz and it's on the test. Okay. A segment is this region here, bounded by the chord of a circle and the circle itself right there. That's the segment. How do I find the area of that shaded region? This is simple geometry, people. It's the area of the sector minus the triangle, right? How do we find the area of a sector? 1/2 r squared theta. So 1/2 r squared theta. And it's in radians, so don't have to change it. Minus the area of the triangle. What's the fastest way to find the area of a triangle if you know 2 sides and the included angle? 1/2 AB sine C. Okay, but see, that's 2 radians, so you better put your calculator in radian mode. Either that or put the radian symbol to override the degree. You guys know the radian symbol is the little r there on your calculator. No, I'm serious, people. If you don't practice on your calculator, the tissues are in the back because we'll have a lot of crying this way. Okay, number 8. Okay, this is the same problem except I'm asking for a different thing. You have a circle of radius 10. Okay, there is a segment with area 95 square units right there. This region is 95 square units right there. What's the measurement of the central angle? See, it's the same problem. How do you find the area of the shaded region, which is the segment? What do you do? A sector minus the triangle. How do you find the area of a sector? 1/2 r squared theta minus the area of the triangle is 1/2 AB sine C. And what we want that equal to? 95 square units. That's your equation. You cannot solve these equations by hand. How do you solve any equation on your calculator? Make one side 0, graph it, and look where it crosses the x-axis. So, what do you punch in on your calculator? Let's bring everything over in this side. 50x minus 50 sine x minus 95. Make one side 0. Graph this on your calculator. Now, what kind of window should I put here? X min, what should x min and x max be? What does x represent? This angle. Can you see that angle got to be positive? And it has to be less than what? 180 degrees, right? So that's what you should make your window. And what, degree mode or radian mode, or it doesn't matter in this problem. Radian mode, so now you got to change back. Because look, anytime you graph a trig function, you got to be in radian mode. And we're graphing a trig function. See, this one you're not graphing, you're just computing, right? That's the difference. And finally, number 9. Okay, in this class, did we discuss this? I think we did, right? If you have a right triangle and you know the hypotenuse and this angle, how do you find this adjacent side? Did we talk about this? H sine, yes or no? Height or EA? 9 or net? Wait, let's both know. Okay then, what's the problem? Okay, here, 2, 2, 3. This is theta and this is theta. Find theta so that the area of this trapezoid will be a maximum. In other words, what do I have to make this angle? Right, because if you make the angle really tiny, like that, if the angle is tiny, is the area bigger or smaller? Yeah, so how do I pick this angle so that the area is a maximum? Now, how do we find maxes and mins? What do we do? We need to write a function so we can graph it on our calculator and calculate the maximum. So what are we trying to maximize? The area. Now, do we know how to find area of a trapezoid? Yes, we took geometry, right? It's 1/2 height, d1 plus d2. This is a very important formula in calculus, I'll just tell you right now. You better know that you walk through the door. Okay, so, yeah, but Mr. Park, how do I figure out the height and... Look, if this is 2 and this is theta, what is this adjacent side? 2 cosine theta. This is 2 sine theta. This is 2 cosine theta. And those of you taking chemistry now, you're going to thank me next year when you have to componentize vectors in physics. 2 sine theta. That's all this is componentizing the vector. Okay, so the area is equal to 1/2 the height. What's the height? This is the height. 2 sine theta times b1 plus b2. This is b1 and that's b2. Those are the two bases. So what is this? 4 cosine theta plus 3 plus b2, which is 3. You want to simplify this? Your calculator doesn't care if it's simplified or not. Simplified or not? Too bad I am. So this cancels that. So this is sine theta, and you get 4 cosine theta plus 6. So graph this on your calculator. y1 equals sine x times 4 cosine x plus 6. And you got to be in radian mode. And you want to see the hump so you can calculate the maximum. And when you set your window, see, some of you guys still just press the graph button. Please let me see it. You're going to set the window! Okay, what's my window? Obviously, theta is positive, so it's got to be bigger than 0. What's the biggest this angle can be? Look at the picture. Here is an angle in a right triangle that's not the right angle. What's the biggest it can be? It can't be bigger than 90 degrees, so pi over 2. Then I guarantee you can see the hump. Okay, you guys better practice this. Oh boy. We are in a heap of trouble. Okay. Okay, so Monday's quiz is going to be exactly like the homework problem, I just change the number. Like if I give you this problem here, instead of 2, 3, 2, what if I make it 3, 4, 3? Is all hell going to break loose? Or instead of 10, make it 9. Change the 95 to 85, all hell breaks loose. Well, we'll find out. I'm telling you on the test, if you guys are not prepared for this test, I'm telling you right now, it's not easy. You got to be prepared. It's not like the last two tests, right? And then polar is not that hard, except that you guys never learned it before. See, that's the problem. Except if you took regular trigonometry. Who took regular trigonometry? 2 people. So you guys did study polar. So you guys have an advantage then. Maybe. Okay, today this is the last thing. Oh my gosh, look at the time. How are we even going to go over the ambiguous case? Okay, now what happens when the triangles are not right triangles? See, if it's a right triangle, you just use SOHCAHTOA, easy. But if it's not a right triangle, what do? You use the law of sines and the law of cosines. What is the law of sines? Sine A over A equals sine B over B equals sine C over C. You know why they call this the law of sines? There's sine in it. Now you might laugh at that, but every single year I tell them to use the law of sines and they're using the law of cosines. No, every single year. What's the law of cosines? C squared equals A squared plus B squared minus 2AB cosine C. You use these formulas when it's not a right triangle. So when you have a right triangle, don't use these formulas, use SOHCAHTOA. But then I had people last year on the test, it's not a right triangle and they're doing SOHCAHTOA. That's a fatal error right there. Oh my goodness. Okay, let's look at some examples. You have a triangle at 3, 5 sides, 3, 5, and 7. Find the measurement of the largest angle. I think this is one of the examples they put in there. You guys should look at those examples. Which one is the largest angle? This one right there. Okay, do you want to call that theta? Okay, what should I use? Law of sines or law of cosines? What did we learn last year? If you are given all 3 sides, which one did I use? Yes, law of cosines. Okay, let's use the law of cosines. When do you, maybe we should just go over it now. When should I use the law of cosines? When you're given all 3 sides or 2 sides and the included angle. That's when you use the law of cosine. Okay, so how do I start it? Now last year you guys had to be treated like little babies, right? You have to go, oh, let's call this one C, and call this one A, and call this one B, right? But no, come on, we're honors. We don't need to do that. Look, whatever side you put on this side, there's the angle over there. So since this is the angle we're trying to find, then of course, you're thinking this is the one I want to make C, right? So look, just follow the form of it. So how do I start it? 7 squared equals 5 squared plus 3 squared minus 2, 5, 3. Right? Because notice, look, if A and B are here, what is A and B there? Cosine C, which in this case is theta. You can call it whatever you want. Okay, let's solve for cosine theta now. What is 2 times 5 times 3? 30 cosine theta is equal to, what do we have? 25 plus 9 minus 49, correct? You put all the numbers on that side. So which is equal to, what's 34 minus 49? Negative 15. So cosine theta is equal to negative 15 divided by 30. That's negative half. Do I need my calculator to figure out that angle? No, this one I can find, right? Because that's a number I know. So what's this angle? 2 pi over 3, or you can write 120 degrees. I don't care if you give me radians or degrees. So take either. But this one would be no calculator. Okay, now when do you use the law of sines? When you're either AAS or ASA. when you know two angles of, well, basically, if you know two angles of a triangle, you know all three angles, right? If you know two angles of a triangle, that's when you use the law of sines. Okay, so example. 37 degrees, no, 71 degrees. This is x and this is 5. Okay, compute what x is. Okay, this is not a right triangle, so we're going to use law of sines or cosines. What's given? Two angles and the included side. That's this one right here, right? Anyways, two angles. You're going to use the law of sines. Okay? Well, in order to use the law of sines, you got to know the opposite angles, right? See how the angle is opposite the side? So, if I want to find this, I have to know this angle there. Do I know it? Yes, because if you know 2, you know the third. What's 37 plus 71? 108, which makes this one 72 degrees. So now we use the law of sines. X over sine 72 degrees is equal to 5 over sine 37. So therefore, x is equal to 5 sine 72 all over sine 37. And you want to be in degree mode for this problem because these are degree measurements. Now you take out your calculator and punch it in. See, I didn't even use calculator. Okay, but these are like really simple problems, okay? Like sometimes this is just going to be within the problem. So you have to get this answer, store it. Are you guys practicing store? You guys better start practicing. Store it, because then now you got to use it in another computation. Because if you're going to use it in another computation, you cannot just take 3 decimal places. You got to use all the decimal places. So you can either write it all down like a little baby, or you can store it in your calculator. You have A through Z. You can store any. You got 26 memories. Okay, and finally, the ambiguous case. Do we have time? I hope we have. What is the ambiguous case? What did we learn last year? This is SSA. We don't write ASS. It's SSA. This is if you're given two sides and a non-included angle, like this. 7, 4, 37 degrees, something like that. Okay, why don't we give names already? A, B, C. So this would be A, B, C. Okay, so what if I were to ask you to compute the value of C? Well, first of all, what does ambiguous case mean? What does ambiguous mean? What? Unclear, exactly. What did we learn last year? When you have an ambiguous case, there could be no solution, there could be one solution, or two solutions, right? Does this even sound familiar? How do you figure out how many solutions there are? What did we learn last year? You draw in the altitude. Okay, every single book, you can look up any book. This is how they teach an ambiguous case. Compute the length of this altitude right here. Let's call it h. How do you compute it? Look, you have a right triangle. You know the hypotenuse of this angle. Therefore, this opposite side is going to be 7 sine 37 degrees. Somebody quickly punch that in on the calculator. Because we can't go, if we don't know what the number is, we can't do anything. And make sure you're in degree mode. Come on, we only got 6 minutes. This is the one, okay, on the test, this is one problem. What? 4.213. Okay, oh, wait a minute. I'm going to change this to a 5. No, let's leave it 4. How many solutions are there then? Yeah, there's none. Because look, if the altitude is 4.2 and this side is 4, this side is not going to even reach this side. It's not going to even form a triangle, right? So that's why you have no solutions. But I can tell you right now, I am never going to give you a problem with no solution because that's dumb. You're only going to do 5 seconds of work and you get the answer. Come on. What would happen if this number here was like 8? How many solutions would there be? 1. Yes. However, this is the part. What would happen if this side is bigger than this number, but smaller than that number, like 5? Then there's two answers. One answer would look like this, but then couldn't you take this side and swing it over on this side like this? So in other words, it would look like this. 7, 5, 37 degrees. Remember in your book last year, they had, I believe they had the picture like this, and they showed it swinging back and forth like that. Does that sound familiar? So you can probably guess, oh, Mr. Park, if you're the teacher, you can make one with 2 solutions, yeah? Yes! Because then that's the one you got to do the most work on. And I'm going to tell you right now, if you only give me one solution, even though on the test I'm going to say, hint, this is the ambiguous case. Okay? There may be more than one solution. If you only give me one, you're only going to get 1 out of 8. 2 out of 8 if you're lucky. Because you only did a little bit work. So how do you find the 2 solutions? So what do you do? Law of sines, law of cosines. Quick, we have 4 minutes left. You can use either one, that's right. I'm going to show you both. Now the books, every book I've seen only shows you the law of sines. They don't show you the law of cosines. That's weak. I think the law of cosines is actually fast way. Okay, so the first thing you do is you compute angle B over here. We're using the law of sines method. So you go sine of B over 7 equals sine of 37 degrees over 5. So you can use this equation to solve for angle B, right? I don't have to do it, right? You guys can do it, right? Okay, so once we find angle B, oh, you can find angle C up here, right? Because once you know 2 angles, you know the third angle, right? And once you know this angle up here, use the law of sines again to find C, right? You just go C over sine C, which you now know, is equal to 5 over sine 37. It's always the opposite one. So then you would use this equation to find the sine C. Okay, but there's 2 answers. This is only one answer. So how do you get the other answer? Well, look, if you swing this on this side to get this picture here, what is the relationship between this angle here and that angle there? They're supplementary because look, this is an isosceles triangle, right? 5 and 5. This angle got to equal to this angle, but then this angle and this angle got to add up to 180. So once you find angle B from this equation, then this angle here is going to be 180 minus that angle B. And then you just do the same thing. Once you got 2 sides of a triangle here, you know this angle, right? And then you can use this equation here to find side C. And that's how you find your 2. So the key for the ambiguous case is you got to know there's 2 solutions. Once you figure out this angle B in this picture, then this angle B here is 180 minus that. That's the key right there. So if you use the law of sines method, there's a lot of things going on. You got to remember plenty of things. But watch this. Let's use the law of cosines method. I would highly suggest you do this one, but it's up to you. All you got to do is, you don't even have to see, if you use the law of cosines method, you don't have to draw the altitude and figure out how many solutions there are. You just use the law of cosines. Okay, how do I start the law of cosines? Do I start it with c squared, 5 squared, or 7 squared? 5 squared, because look, this is the only angle you know. It's opposite this side here. So 5 squared is equal to c squared plus 7 squared minus 2c7 cosine of 37 degrees. What kind of equation is this? What kind of equation? Linear, quadratic, cubic, quartic? It's quadratic. The highest power is second power. See? Anyway, how do you solve any equation on your calculator? What do you do? You make one side 0 and you graph it. So on your calculator, you just graph this. Make one side 0. So you got x squared. And you can just punch it in like this. Come on. Or I guess we can multiply 2 and 7, right? And then minus 25. You don't even have to add the... Anyway, punch this in on your calculator and then graph it. Okay, now, what if you see this? There's 2 solutions. One there and one there. You don't see, that's why you don't even have to know. You just look. What if you graph this parabola on your calculator and it looks like this? Oh, there's only one solution. Yeah, but what about that one? How can you have negative? What if you graph it on your calculator and it looks like that? No solution. See, so you don't even have to know anything if you use the law of cosines method. I've never seen a book ever that teaches you that. I don't know why not. That's like way easier. But it's up to you. I leave it up to you. So when you do the homework, you have to do the homework, or you're just gonna get be blown out of the water on Wednesday. You cannot fake your way through this chapter. You cannot. Oh, I thought we were going to finish early, but I guess. Oh, baby. And we didn't even play a Christmas carol.